Good day, everyone. I am Siti Ashima P. Adjong, the first presenter for Group 2. We will discuss Chapter 2 entitled Auditing IT Governance Controls. So here are the learning objectives for this chapter. After studying this chapter, you should understand the risks of incompatible functions and how to structure the IT function. Be familiar with the controls and precautions required to ensure the security of an organization's computer facilities. Understand the key elements of a disaster recovery plan and to be familiar with the benefits, risks, and audit issues related to IT outsourcing. So the report is divided into four parts by the four presenters. I will be the first presenter providing you the information technology governance definition up until the distributed model. The second presenter would be Ms. Barandia discussing the risks associated with DDP, followed by Miss Lantud, our third presenter, and then our fourth presenter, Miss Manua. So please take note of these few key terms found on the textbook. Okay, so to start off, what is IT governance? IT, or Information Technology Governance, is a relatively new subset of corporate governance that focuses on the management and assessment of strategic IT resources. Key objectives of IT governance are to reduce risk and ensure that investments in IT resources add value to the corporation. The interest in IT governance is due to the ongoing need within organizations to focus value creation efforts on an organization's strategic objectives of IT and to better manage the performance of those responsible for creating this value in the best interest of all stakeholders. IT governance control. So although all IT governance issues are important to the organization, not all of them are matters of internal control under SOX that may potentially impact the financial reporting process. In this chapter, we consider three IT governance issues that are addressed by SOX and the COSO internal control framework. So these are first the organizational structure of the IT function, the computer center operations, which will be discussed by the second presenter, and disaster recovery planning, followed by the third presenter. So first IT governance issue is the organizational structure of the IT or information technology function. The organization of the IT function has implications for the nature and effectiveness of internal controls, which in turn has implications for the audit. So in this section, some important control issues related to IT structure are examined. These are illustrated through two organizational models. First, the centralized approach or centralized data processing, and the distributed approach or the distributed model. However, we must take note that most organizational structures embody elements of both models. So the first organizational model is the centralized data processing or the centralized approach. Under the centralized data processing model, all data processing is performed by one or more large computers housed at a central site that serves users throughout the organization. Figure 2.1 illustrates this approach in which IT services activities are consolidated and managed as a shared organization resource, and users compete for these resources on the basis of need. The IT services function is usually treated as a cost center whose operating costs are charged back to the end users. So Figure 2.2 illustrates a centralized IT services structure and shows its primary service areas, the database administration, data processing, and systems development and maintenance. So for database administration, centrally organized companies maintain their data um, resources in a central location that is shared by all end users. So in this shared data arrangement, an independent group headed by the database administrator or the DBA is responsible for the security and integrity of the database. The data processing group manages the computer resources used to perform the day-to-day processing of transactions, and it consists of the following organizational functions: the data conversion, computer operations, and the data library. So the data conversion function transcribes transaction data from hard copy source documents into computer input. So for example, the data conversion could involve keystroking sales orders into a sale order application in modern systems. For computer operations, the electronic files produced in data conversion are later processed by the central computer, which is managed by the computer operations groups. Accounting applications are usually executed according to a strict schedule that is controlled by the central computer's operating system. Another organizational function is the data library, which provides safe storage for the offline data files. Those files could be backups or current data files. The data library is used to store original copies of commercial software and their licenses for safekeeping. A data librarian who is responsible for the receipt, storage, retrieval and custody of data files controls access to the library. The librarian issues data files to computer operators in accordance with program requests and takes custody of files when processing or backup procedures are completed. The third service area is the systems development and maintenance. The information systems needs of users are met by two related functions: the system development and the systems maintenance. The system development group is responsible for analyzing user needs and for designing new systems to satisfy those needs. So the participants in system development activities include system professionals and users and stakeholders. Systems professionals gather facts about the user's problem, analyze the facts, and formulate a solution. So the product of their efforts is a new information system. And users are those for whom the system is built. They are the managers who receive reports from the system and the operations personnel who work directly with the system as part of their daily responsibilities. Another participant is the stakeholders. They are individuals inside or outside the firm who have an interest in the system but are not end users. They include accountants, internal auditors, external auditors, and others who oversee systems development. Once a new system has been designed and implemented, the systems maintenance group assumes responsibility for keeping it current with user needs. The term maintenance refers to making changes to program logic to accommodate shifts in user needs over time. Segregation of incompatible IT functions. The previous chapter stressed the importance of segregating incompatible duties within manual activities. Specifically, operational tasks should be segregated to: first, separate transaction authorization from transaction processing. Separate record keeping from asset custody. And divide transaction processing tasks among individuals such that short of collusion between two or more individuals, fraud would not be possible. So the IT environment tends to consolidate activities. A single application may authorize, process, and record all aspects of a transaction. Thus, the focus of segregation control shifts from the operational level to higher level organizational relationships within the computer services function. Using the organizational chart in Figure 2.2 as a reference, the interrelationships among systems development, systems maintenance, database administration, and computer operations activities are examined next. So separating systems development from computer operations. The segregation of systems development, both new systems development and system maintenance, and operations activities is of the greatest importance. The relationship between these groups should be extremely formal, and their responsibility should not be commingled. Systems development and maintenance professionals should create and maintain systems for users and should have no involvement in entering data or running applications like computer operations. Separating database administration from other functions. So another important organizational control is the segregation of the database administrator or the DBA from other computer center functions. So the DBA function is responsible for a number of critical tasks pertaining to database security, including creating the database schema and user views, assigning database access authority to users, monitoring database usage, and planning for future expansion. Delegating these responsibilities to others who perform incompatible tasks threatens database integrity. Thus, we see from Figure 2.2 how the database administrator function is organizationally independent of operations, systems development, and maintenance. Separating new systems development from maintenance. Some companies organize their in-house systems development function into two groups, the systems analysis and the applications programming. The systems analysis group works with the users to produce detailed designs of the new systems, while the programming group codes the programs according to these design specifications. Although a common arrangement, this approach is associated with two types of control problems: inadequate documentation and the potential for program fraud. Poor quality systems documentation is a chronic IT problem and a significant challenge for many organizations seeking SOX compliance. There are at least two explanations for this phenomenon. First, documenting systems is not as interesting as designing, testing, and implementing them. Systems professionals much prefer to move on to an exciting new project rather than document one just completed. The second possible reason for poor documentation is job security. When a system is poorly documented, it is difficult to interpret, test, and debug. Therefore, the programmer who understands the system maintains bargaining power and becomes relatively indispensable. Another control problem is the program fraud. When the original programmer of a system is also assigned maintenance responsibility, the potential for fraud is increased. Program fraud involves making unauthorized changes to program modules for the purpose of committing an illegal act. The original programmer may have successfully concealed fraudulent code among the thousands of lines of legitimate code and the hundreds of modules that constitute a system. For the fraud to work successfully, however, the programmer must be able to control the situation through exclusive and unrestricted access to the application's programs. A superior structure for systems development. Figure 2.2 presents a superior organizational structure in which the systems development function is separated into two different groups: new systems development and systems maintenance. The new systems development group is responsible for designing, programming, and implementing new systems projects. Upon successful implementation, responsibility for the system's ongoing maintenance falls to the systems maintenance group. This restructuring has implications that directly address the two control problems I discussed a while ago, the inadequate documentation and the program fraud. So first, documentation standards are improved because the maintenance group requires documentation to perform its maintenance duties. Second, denying the original programmer future access to the program deters program fraud, so that the fraudulent code, once concealed within the system, is out of the programmer's control and may later be discovered, increases the risk associated with program fraud. So let's go to the distributed model. So for many years, economies of scale favored large, powerful computers and centralized processing. Today, however, small, powerful, and inexpensive systems have changed this picture dramatically. An alternative to the centralized model is the concept of distributed data processing, or the DDP. The topic of DDP is quite broad, touching upon such related topics as end-user computing, commercial software, networking, and office automation. Simply stated, DDP involves or reorganizing the central IT function into small IT units that are placed under the control of end users. So the IT units may be distributed according to business function, geographic location, or both. Figure 2.4 presents two alternative DDP approaches. Alternative A is actually a variant of the centralized model. The difference is that terminals are distributed to end users for handling input and output. So this eliminates the need for the centralized data conversion groups. Since the user now performs this task under this model, however, systems development, computer operations, and database administration remain centralized. So in alternative B is a significant departure from the centralized model. So this alternative distributes all computer services to the end users, where they operate as standalone units. The result is the elimination of the central IT function from the organizational structure. So notice the interconnections between the distributed units in figure 2.4. So these connections represent a networking arrangement that permits communication and data transfers between the units.
Here we are going to discuss the organizational risks that need to be considered when implementing DTP. We'll focus here on the issues that carry control implications that auditors should recognize. There are actually potential problems in implementing this one, such as the inefficient use of resources, the destruction of audit trails, inadequate segregation of duties, increased potential for programming errors and systems failures, and the lack of standards. Inefficient use of resources, there are three types of risks. First, the risk of mismanagement of organization-wide IT resources by end users. Effective IT governance requires central management and monitoring of resources kapag ang buong organization IT resources ay nag-exceed sa threshold amount. For example, 5% of the total operations budget. Number 2, DDP can increase the risk of operational inefficiencies because of redundant tasks being performed within the end user committee. Kapag paulit-ulit na yung task performed by the end user committee, mag-i-increase yung operational inefficiencies. For example, application programs created by one user pwedeng i-redesign from scratch rather than shared because of redundancy. This situation has implications for data accuracy and redundancy. Third one is the DDP environment poses a risk of incompatible hardware and software among end-user functions. Distribution ng responsibilities for IT purchases sa mga end users ay pwedeng mag-result ng uncoordinated and poorly conceived decisions. For an instance, decision makers from different units of the organization might settle on dissimilar and incompatible operating systems. Here, hardware and software incompatibilities can degrade and disrupt connectivity between units, causing the loss of transactions and possible destruction of audit trails. Next potential problem to be discussed here is the destruction of audit trails. Ang audit trail ay nagpo-provide ng linkage between companies' financial activities and the financial statements that report those financial activities. Auditors basically use the audit trail to trace selected financial transactions from the source documents that capture the events through the journals, subsidiary ledgers, general ledger accounts that recorded the events, and ultimately to the financial statements themselves. The audit trail is critical to the auditor's attest service. Sa DDP systems, the audit trail consists of a set of digital transaction files and master files that reside in a part or entirely on end-user computers. Should an end-user inadvertently delete one of the files, the audit trail could be pwede siyang masira or maging unrecoverable. Similarly, if an end user inadvertently inserts transaction errors into an audit trail file, pwede itong mag-corrupt. Next one is inadequate segregation of duties. Achieving an adequate segregation of duties may not be possible in some distributed environments. The distribution of IT services to users may result in the creation of small independent units that do not permit the desired separation of incompatible functions. For example, it would be such a fundamental violation of internal control kapag iisang person ang magsusulat ng application programs, perform program maintenance, enter transaction data into the computer, and siya rin ang mag-ooperate ng computer equipment. Another is hiring qualified professionals. End-user managers may lack the IT knowledge to evaluate the technical credentials and relevant experience of candidates applying for IT professional positions. If the organizational unit into which a new employee is entering is small, the opportunity for personal growth, continuing education, and promotion may be limited. For these reasons, pwedeng maka-experience ng difficulty attracting highly qualified personnel. Yung risk ng programming errors and failures ay mag-increase directly sa level of employee incompetence. Last potential problem is lack of standards. Because of distribution of responsibility in the DDP environment, standards for developing and documenting systems, choosing programming languages, acquiring hardware and software, and evaluating performance may be unevenly applied or non-existent. Opponents of DDP argue that the risks associated with the design and operation of a DDP system are made tolerable only if such standards are consistently applied. The next thing we'll discuss here is the advantages of DDP. This part considers potential advantages of DDP including the following. First one is the cost reductions. For many years, achieving economies of scale was the principal justification for the centralized data processing approach. The economics of data processing favored large, expensive, powerful computers. The wide variety of needs that centralized systems were expected to satisfy also called for computers that were highly generalized and employed complex operating systems. The overhead associated with running such a system, however, can diminish the advantages of its raw processing power. Thus, for many users, large centralized systems represented expensive overkill that they should escape. Next is improved cost control responsibility. End user managers carry the responsibility for the financial success of their operations. This responsibility requires that they properly empowered with the authority to make decisions about the resources that influence their overall success. When managers are precluded from making the decisions necessary to achieve their goals, Their performance can be negatively influenced. A less aggressive and less effective management may evolve. Improved user satisfaction. Perhaps the most often cited benefit of DDP is improved user satisfaction. DDP proponents claim that distributing system to end users improves three uh, areas of need that too often go unsatisfied in the centralized model. Number one, as previously stated, user desire to control the resources that influence their profitability. Second, users want systems professionals, such as analysts, programmers, and computer operators, to responsive to their specific situation. And lastly, users want to become more actively involved in developing and implementing their own systems. Next is backup flexibility. The final argument in favor of DDP is the ability to back up computing facilities to protect against potential disasters such as fires, floods, sabotage, and earthquakes. The only way to back up a central computer site against such disasters is to provide a second computer facility. Next to be discussed here is the controlling of the DDP environment. DDP carries a certain leading edge prestige value that, during an analysis of its pros and cons, may overwhelm important considerations of economic benefit and operational feasibility. Some organizations have made the move to DDP without considering fully whether the distributed organizational structure will better achieve their business objectives. Implementing a corporate IT function. The completely centralized model and the distributed model represent extreme positions on a continuum of structural alternatives. The needs of most firms fall somewhere between these endpoints. Often, the control problems previously described and can be addressed by implementing a corporate IT function. Here are some of the services provided. First one is the central testing of commercial software and hardware. This allows the organization to effectively centralize the acquisition, testing, and implementation of software and hardware and avoid many problems discussed earlier. Next is user services. A valuable feature of the corporate group is its user services function. This activity provides technical help to users during the installation of new software and in troubleshooting hardware and software problems. Next is a standard setting body. The relatively poor control environment imposed by the DDP model can be improved by establishing some central guidance. The corporate group can contribute to this goal by establishing and distributing to user areas appropriate standards for systems development, programming, and documentation. Next one is personal review. The corporate group is often better equipped than users to evaluate the technical credentials of prospective systems professionals. Although the systems professional will actually be part of the end user group, the involvement of the corporate group in employment decisions can render a valuable service to the organization. The next one that we'll be talking about is the computer center. Accountants routinely examine the physical environment of the computer center as part of their annual audit. The objective of this section is to present computer center risks and the controls that help to mitigate risk and create a secure environment. The following are areas of potential exposure that can impact the quality of information, accounting records, transaction processing, and the effectiveness of other more conventional internal controls. The physical location of the computer center directly affects the risk of destruction to a natural or man-made disaster. To the extent possible, the computer center should be away from human-made and natural hazards such as processing plants, gas and water mains, airports, high crime areas, floodplains, and geological faults. The center should be away from normal traffic, such as the top floor of a building or in a separate self contained building. Locating a computer in the basement building increases its risk to floods. Next one is construction. Ideally, a computer center should be located in a single-story building of solid construction with controlled access. Utility lines should be underground. The building windows should not open and an air filtration system should be in a place that is capable of extracting pollens, dusts, and dust mites. Next one is access. Access to the computer center should be limited to the operators and the employees who work there. Physical controls, such as locked doors, should be employed to limit access to the center. Access should be controlled by a keypad or swipe card. Through fire exits with alarms are necessary. To achieve a higher level of security, access should be monitored by closed-circuit cameras and video recording systems. Computer centers should also use sign-in logins for programmers and analysts who need access to correct program errors. The computer center should maintain accurate records of all such traffic. Next one is the air conditioner. Computers function best in an air-conditioned environment, and providing adequate air conditioning is often a requirement of the vendor's warranty. Computers operate best in a temperature range of 70 to 75 degrees Fahrenheit and a relative humidity of 50%. Next one is fire suppression. Fire is the most serious threat to a firm's computer equipment. Many companies that suffer computer center fires go out of business because of the loss of critical records, such as accounts receivable. The implementation of an effective fire suppression system requires consultation with specialists. However, some of the major features of such system include the following. Number one, automatic and manual alarms should be placed in strategic location around the installation. These alarms should be connected to permanently staffed firefighting stations. Next one is there must be an automatic fire extinguishing system that dispenses the appropriate type of suppressant for the location. For example, spraying water and certain chemicals on a computer can do as much damage as the fire. Third one is the manual fire extinguishers should be placed at strategic locations. Fourth is the building should be of sound construction to withstand water damage caused by fire suppression equipment. Fire exits should also be clearly marked and illuminated during a fire. Next is fault tolerance. Fault tolerance is the ability of the system to continue operation when part of the system fails because of hardware failure, application program error, or operator error. Implementing fault tolerance control ensures that no single point of potential system failure exists. Total failure can occur only if multiple components fail. Two examples of fault tolerance technologies are discussed next. There are two examples of fault tolerance technologies. First one is the redundant arrays of independent disks, or RAID. RAID involves using parallel disks that contain redundant elements of data and applications. If one disk fails, the lost data are automatically reconstructed from the redundant components stored on the other disks. Second one is the uninterruptible power supplies. Commercially provided electrical power presents several problems that can disrupt the computer center operations, including total power failures, brownouts, power fluctuations, and frequency variations. The equipment used to control these problems includes voltage regulators, surge protectors, generators, and backup batteries. In the event of a power outage, these devices provide backup power for a reasonable period to allow commercial power service restoration. In the event of an extended power outage, The backup power will allow the computer system to shut down in a controlled manner and prevent data loss and corruption that would otherwise result from an uncontrolled system crash.
Assalamualaikum and good day everyone. I am Jamalia Lantud, your third presenter for this chapter. And as for my part, I will be discussing audit objectives, audit procedures down to disaster recovery planning. Audit objectives. The auditor's objective is to evaluate the controls governing computer center security. Specifically, the auditor must verify that physical security controls are adequate to reasonably protect the organization from physical exposures. Also, an auditor must verify that insurance coverage on equipment is adequate to compensate the organization for the destruction of or damage to its computer center. Next, audit procedures. So, there are several tests of physical security controls in audit procedures. First is the test of physical construction. So, the auditor should obtain architectural plans to determine that the computer center is solidly built of fireproof material. Meaning there should be adequate drainage under the raised floor to allow water to flow away in the event of water damage from a fire in an upper floor or from some other source. So, in addition, the auditor should assess the physical location of the computer center. So, dapat nakalocate yung facility sa area which is less exposed to fire, civil unrest, or yung public disturbance and other hazards. Next is the second is the test of fire detection system. The auditor should establish that fire detection and suppression equipment, both manual and automatic, are in place and tested regularly. The fire detection system should detect smoke, heat, and combustible fumes. The evidence may be obtained by reviewing official fire marshal records of tests which are stored at the computer center. So, third is the test of access control. The auditor must establish that routine access to the computer center is restricted to authorized employees. Details about visitor access, which is by programmers and others, such as arrival and departure times, purpose, and frequency of access can be obtained by reviewing the access log. So, to establish the veracity of this document, the auditor may covertly observe the process by which access is permitted or review videotapes from cameras at the access point if they are being used. Fourth is the test of RAID. Most systems that employ RAID provide a graphical mapping of the redundant disk storage. So from this mapping, the auditor should determine if the level of RAID in place is adequate for the organization given the lead of business risk associated with disk failure. So if an organization is not employing RAID, the potential for a single point of system failure exists. The auditor should review with the system administrator alternative procedures for recovering from a disk failure. Fifth one is the test of uninterruptible power supply. The computer center should perform periodic tests of the backup power supply to ensure that it has sufficient capacity to run the computer and air conditioning. These are extremely important tests and their results should be formally recorded. As a firm's computer systems develop, its dependency increases, backup power needs are likely to grow proportionally. Indeed, without such tests, an organization may be unaware that it has outgrown its backup capacity until it is too late. Last one is the test for insurance coverage. The auditor should annually review the organization's insurance coverage on its computer hardware, software, and physical facility. The auditor should verify that all new acquisitions are listed on the policy and that obsolete equipment and software have been deleted. The insurance policy should reflect management's needs in terms of extent of coverage. For example, the firm may wish to be partially self-insured and require minimum coverage. But on the other hand, the firm may seek complete replacement cost coverage. Now let's move on to disaster recovery planning. Before that, let us find out what are the types of disasters. So, disasters such as earthquakes, floods, sabotage, and even power failures can be catastrophic to an organization's computer center and information systems. So, this this diagram shows the three categories of disaster that can rob an organization of its IT resources. Um, the natural disasters, human-made disasters, and system failure are the three types of disaster. So, natural disasters such as hurricanes, widespread flooding, and earthquakes are the most potentially devastating of the three from a societal perspective because they can simultaneously impact many organizations within the affected geographic area. Whereas human-made disasters such as sabotage or errors can be just as destructive to an individual organization but tend to be limited in their scope of impact. System failures such as power outage or a hard drive failure are generally less severe but are the most likely to occur. So all of these disasters can deprive an organization of its data processing facilities, halt those business functions that are performed or aided by computers, and impair the organization's ability to deliver its product or services. So, in other words, the company loses its ability to do business. The more dependent an organization is on technology, the more susceptible it is to these types of risk. For businesses such as Amazon.com or eBay, the loss of even a few hours of computer processing capability can be catastrophic. So, disasters shown here cannot be prevented or evaded. Once stricken, the victim firm's survival will be determined by how well and how quickly it reacts. Therefore, with careful contingency planning, the full impact of a disaster can be absorbed and the organization can recover. So, to survive such an event, companies develop recovery procedures and formalize them into a disaster recovery plan. So, DRP is a comprehensive statement of all actions to be taken before, during, and after any type of disaster. Although the details of each plan are unique to the needs of the organization, all workable plans possess four common features, and these are to identify critical applications, create a disaster recovery team, provide site backup, and specify backup and offsite storage procedures. The first essential element of a DRP is to identify the firm's critical applications and associated data files. Recovery efforts must concentrate on restoring those applications that are critical to the short-term survival of the organization. So, obviously, over the long term, all applications must be restored to pre-disaster business activity levels. However, the DRP is a short-term document that should not attempt to restore the organization's data processing facility to full capacity immediately following the disaster. To do so would divert resources away from critical areas and delay recovery. The plan should therefore focus on short-term survival, which is at risk in any disaster scenario. So, for most organizations, short-term survival requires the restoration of those functions that generate cash flows sufficient to satisfy short-term obligations. So, for example, a particular firm has these following functions that affect their cash flow position. So, such as customer sales and service, fulfillment of legal obligations, down to trade accounts and payroll. So, the computer applications that support these business functions directly are critical. Hence, these applications should be identified and prioritized in the restoration plan. Next, creating a disaster recovery team. Recovering from a disaster depends on timely corrective action. Delays in performing essential tasks prolongs the recovery period and diminishes the prospects for a successful recovery. So, to avoid serious omissions or duplication of effort during implementation of the contingency plan, task responsibility must be clearly defined and communicated to the personnel involved. This chart shows the composition of a disaster recovery team. The team members should be experts in their areas and have assigned tasks. Following a disaster, team members will delegate subtasks to their subordinates. It should be noted that traditional control concerns do not apply in this setting. The environment created by the disaster may make it necessary to violate control principles such as segregation of duties, access controls, and supervision. So, uh, the objective in a second site facilities group is to prepare backup site for operation and acquire hardware from vendors. As for program and data backup group, they are assigned to provide current versions of all critical applications, data files, and documentations. And as for data conversion and data control group, they are assigned to re-establish the data conversion and data control functions necessary to process critical applications. Now let's move on to the third common feature of a DRP, which is to provide second site backup. So, a necessary ingredient in a DRP is that it provides for duplicate data processing facilities following a disaster. Among the options available, the most common are mutual aid pack, empty shell or cold site, recovery operations center or hot site, and internally provided backup. So, the first one is the mutual aid pact. Mutual aid pact is an agreement between two or more organizations with compatible computer facilities to aid each other with their data processing needs in the event of a disaster. In such an event, the host company must disrupt its processing schedule to process the critical transactions of the disaster-stricken company. Second is the empty shell. The empty shell or cold site plan is an arrangement wherein the company buys or leases a building that will serve as a data center. In the event of a disaster, the shell is available and ready to receive whatever hardware the temporary user needs to run essential systems. So, this approach, however, has a fundamental weakness. Recovery depends on the timely availability of the necessary computer hardware to restore the data processing function. So, management must obtain assurance through contracts with hardware vendors that, in the event of a disaster, the vendor will give the company's needs priority. An unanticipated hardware supply problem at this critical juncture could be a fatal blow. Third is the Recovery Operations Center. It is a fully equipped backup data center that many companies share. In addition to hardware and backup facilities, ROC or Recovery Operations Center service provides offer a range of technical services to their clients who pay an annual fee for access rights. Last is the internally provided backup. Larger organizations with multiple data processing centers often prefer the self-reliance that creating internal access capacity provides. This permits firms to develop standardized hardware and software configurations, which ensure functional compatibility among their data processing centers and minimize cutover problems in the event of a disaster. Down to the last common feature of a DRP, which is the backup and offsite storage procedures. All data files, applications, documentation, and supplies needed to perform critical functions should be automatically backed up and stored at a secure offsite location. Data processing personnel should routinely perform backup and storage procedures to obtain and secure these critical resources. So the first backup procedure is operating system backup. So if a company uses a cold site or other method of site backup that does not include a compatible operating system, procedures for obtaining a current version of the operating system need to be clearly specified. Second procedure is the application backup. So based on results obtained in the critical applications step discussed, the DRP should include procedures to create copies of current versions of critical applications. In the case of commercial software, this involves purchasing backup copies of the latest software upgrades used by the organization. Third, third, um, third procedure is the backup data files. So the state-of-the-art in database backup is the remote mirrored site, which provides complete data currency. Take note that not all organizations are willing or able to invest in such backup resources. However, as a minimum, databases should be copied daily to high-capacity, high-speed media such as tape or CDs, or even DVDs and secured off-site. In the event of a disruption, reconstruction of the database is achieved by updating the most current backed up version with subsequent transaction data. Next procedure is the backup documentation. The system documentation for critical applications should be backed up and stored off-site along with the applications. System documentation can constitute a significant amount of material, and the backup process is complicated further by frequent application changes. However, documentation backup may be simplified and made more efficient through the use of computer-aided software engineering or case documentation tools. Also, the DRP should include a provision backing up and user manuals because the individuals processing transaction under disaster conditions may not be usual staff who are familiar with the system. Backup supplies and source documents is the next procedure, and the organization should create backup inventories of supplies and source documents used in processing critical transactions. An example of critical supplies are check stocks, invoices, purchase orders, and any other special purpose forms that cannot be obtained immediately. The DRP should specify the types and quantities needed of these special items. Last procedure is testing the DRP. So the most neglected aspect of contingency planning is testing the DRP. Nevertheless, DRP tests are important and should be performed periodically. Tests measure the preparedness of personnel and identity omissions or bottlenecks in the plan. So, all in all, the auditor should verify that management's disaster recovery plan is adequate and feasible for dealing with a catastrophe that could deprive the organization of its computing resources. So here ends my report, and thank you for listening.
Auditor should verify that management's disaster recovery plan is adequate and feasible for dealing with a catastrophe that could deprive the organization of its computing resources. In verifying that management's DRP is realistic solutions for dealing with a catastrophe, these are the following audit procedures. The first one is a site backup, second is critical application list, a software backup, data backup, backup supplies, documents and documentations, disasters recovery team. The first one is the site backup. So, The auditor should evaluate the adequacy of the backup site arrangement, system incompatibility, and human nature both greatly reduce the effectiveness of the mutual aid pact. Auditors should be skeptical of such arrangements for two reasons. First is the sophistication of the computer system may make it difficult to find a potential partner with a compatibility configuration. The second one is most firms do not have the necessary excess capacity to support a disaster-stricken partner while also processing their own work. So, more viable but expensive options are the empty shell and recovery operation center. So, these two must be examined carefully. So, if the client organization is using the empty shell method, then the auditor needs to verify the existence of valid contracts with hardware vendors that guarantee delivery of needed computer hardware with minimum delay after the disaster. So, if the client is a member of ROC, then the auditor should be concerned about the number of ROC members of their geographic dispersion. So, the second one is the critical application list. So, in critical application list, the auditor should review the list of critical applications to ensure that it is complete. So, missing applications can result in a failure to recovery, of course, and then the sum is true, however, for restoring unnecessary applications. And then to include applications on the critical list that are not needed to achieve short-term survival can misdirect resources and distract attentions from the primary objects during the recovery period. Our next procedures is the software backup. In software backup, auditors should also verify that the applications stored off-site are current by comparing their version number with those of the actual application in use. So, auditors should also verify that copies of critical applications and operation system are stored off-site. And application version numbers is explained in detail in chapter 5. So, the next one is our data backup. In data backup, the auditor should verify that critical data files are backed up in accordance with the DRP. So, so our next one is the backup supplies, documents, and documentations, which is the system documentation supplies and source documents needed to process critical transactions should be backed up and stored off-site. The auditor should verify that the types of quantities of items specified in the DRP, such as checks, stocks, invoices, purchases, orders, and any special purpose forms exist in secure location. Now, the last one is the disaster recovery team. In disaster recovery team, the DRP, or what we call DRP, should clearly list the names, addresses, and emergency telephone number of the disaster recovery team members. And the auditor should verify that members of the team are current employees and are aware of their assigned responsibilities. On one occasion, while reviewing DRP, the auditors discovered that the team leader listed in the plan had been deceased for 9 months. The cost risks and responsibilities associated with maintaining an effective corporate IT function are significant. Thus, many executives have therefore opted to outsource their IT functions to third-party vendors who have over responsibility for the management of IT assets and staff for delivery of IT services such as data entry, data center operations, applications development, applications maintenance, and network management. So, our outsourcing benefits is that it includes the improved core business of performance, of course, and improve the IT performance because of the vendor's expertise, and then reduce its IT costs. Its assets is divided into commodity assets and transaction cost economics. In commodity assets, it includes such things as network management, system operations, server maintenance, and help desk function. This is the unique to a particular organization and are thus easily acquired in the marketplace. Unlike specific IT assets, which includes which may be tangible, intellectual, or human, and includes system development and application maintenance, data warehousing, and highly skilled employees trained to use organization-specific software. And thus, specific IT assets, in contrast, are unique to the organization and support its strategic objectives. Because of their idiosyncrasical nature, specific assets have little value outside their current use. So, the core competency theory, which argues that an organization should focus exclusively on its core business competencies while allowing outsourcing vendors to efficiently manage the non-core areas such as the IT functions. This premise, however, ignores an important distinction between commodity and specific IT assets. On transaction cost economics, or known as TCE theory, is in conflict with the core competency school by suggesting that the firms should retain certain specific non-core. So IT assets in-house. Because of their esoteric nature, specific assets cannot be easily replaced once they are given up in outsourcing arrangements. Therefore, if the organization should decide to cancel its outsourcing contracts with the vendor, it may not be able to return its pre-outsourced state. On the other hand, TCE theory supports the outsourcing for commodity assets which are easily replaced or obtained from alternative vendors. So the risk inherent to IT outsourcing. Um, on risk inherent to IT outsourcing, large scale of IT outsourcing events are risky endeavors, partly because of the sheer size of these financial deals, but also because of their nature. The level of risk is related to the degree of asset specificity of the outsourced function. So the following section outline some well documented, such as failure to perform, vendor exploitation, outsourcing costs exceeds benefits, reduced security, and loss of strategic advantages. So the first one is the failure to perform. So once a client's firm has outsourced specific IT assets, its performance becomes linked to the vendor's performance, of course. So the negative implication of such dependency are illustrated in the financial problems that have plagued the huge outsourcing vendors of Electronic Data System Corporation or EDS. EDS terminated 7,000 employee, which impacted its ability to serve other clients. Following an 11-year low in share prices, EDS stockholders filed a class action lawsuit against the company. Clearly, vendors experienced such a serious financial and legal problems, threatening the viability of their clients also. So the next one is the vendor exploitation. On vendor exploitation, large-scale IT sourcing involves transferring to a vendor specific assets such as the design, development, and maintenance of unique business applications that are critical to the organization's survival. Specific assets which valuable to the client are of little value of the vendor beyond the immediate contract with the client. So indeed, they may well be valueless should the client organization go out of business. So because the vendor assumes a risk by acquiring the assets and can achieve no economics of scale by employing them elsewhere, the client organization will pay a premium to transfer such functions to a third party. So further, once the client's firm has divested itself of such specific assets, it becomes dependent on the vendor. So the vendor may exploit this dependency by raising service rates to an exorbitant level as the client's IT needs developed over time beyond the original contract terms. It runs the risk that new incremental service will be negotiated at a premium. This dependency may threaten the client's long-term flexibility, agility, competitiveness, and result in even greater vendor dependency. So the next one is the outsourced cost exceeds benefit. In this one, IT sourcing has been criticized on the grounds that unexpected costs arise and the full extent of expected benefits are not realized. So, on one survey revealed that 47% of 66 firms surveyed reported that the cost of IT outsourcing exceeded outsourcing benefits. So, one reason for this is that outsourcing clients often fail to anticipate the costs of vendor selection, contracting, and the transitioning of IT operations to the vendors. Next is the reduced security. It reduces security. So information outsourced to offshore IT vendors raises unique and serious questions regarding internal control and the protection of sensitive personal data. When corporate financial systems are developed and hosted overseas, and program code is developed through interface with the host company's network, US corporations are at risk of losing control of their information. So, in that case, a large degree of US firms are reliant on the outsourcing vendors' security measures, data access policies, and the policy laws of the host country. So, for example, a woman in Pakistan obtained patient sensitive medical data that the University of California Medical Center in San Francisco that gained access to the data from a medical transcription vendor from whom she worked. The woman threatened to publish their two records on the internet if she did not get raised in pay. So terrorism in Asia and the Middle East raises additional security concerns for companies outsourcing technology offshore. So for example, it has sampled on March 5, 2005. The police in Delhi, India arrested of cell of suspected terrorists who were planning to attack outsourcing firm in Bangalore, India. And the last one is the loss of strategic advantage. So IT outsourcing may affect incongruence between the firm's IT strategic planning and its business planning functions. So organizations that use IT strategically must align business strategy and IT strategy or run the risk of a decreased business performance. So, to promote such alignment, firms need IT managers and chief information officers or CIOs who have a strong working knowledge of the organization's business. So, a survey of 213 IT managers in the financial service industry confirmed that a firm's IT leadership needs to be closely aligned with the firm's competitive strategy. Indeed, some argue that the business competencies of CIOs is more important than their IT competence in facilitating strategy congruence. So to accomplish such alignment necessitates a close working relationship between corporate management and IT management and the concurrent development of business and IT strategies. This, however, is difficult to accomplish when IT planning is geographically redeployed offshore or even domestically. So further, because the financial justification of IT outsourcing depends upon the vendor achieving economies of scale, the vendor is naturally driven towards seeking common solution that may be used by many clients rather than creating unique solutions for each of them. So this fundamental underpinning of IT outsourcing is inconsistent with the client's pursuit of strategy advantage in the marketplace. So let's move on to the audit implication of IT outsourcing. So management may outsource its organization's IT functions, but it cannot outsource its management's responsibilities under SOX for ensuring adequate IT internal controls. So according to auditing standard number 2, the use of a service organization does not reduce management's responsibilities to maintain effective internal control over financial reporting. Rather, user management should evaluate controls of the service organization as well as related controls of the user company when making its assessment about internal control over financial reporting. Therefore, if an audit client firm outsources IT function to a vendor that processes its transactions, hosts key data, or perform other significant services, the auditor will need to conduct a evaluation of the vendor's organization control or alternative obtain of SS number 70 auditor's report from the vendor's organization. So, In a statement on auditing standard number 70 or SAS 70 as a definitive standard by which clients organizations auditor can gain knowledge that controls at the third party vendors are adequate for to prevent or detect material errors that could impact the client's financial statements. The SAS 70 report, which is prepared by the vendor's auditor, attests to the adequacy of the vendor's internal control. This is the means by which an outsourcing vendor can obtain a single audit report that may be used by its clients. Auditors thus preclude the need for each client from auditor to conduct its own audit of the vendor's organization's internal controls. So So this illustration has a 70 report works in relation to the vendor. So the client's firms and their respective auditor, the outsourcing vendor serves clients 1, 2, 3, and 4 with various IT services. The internal controls over the outsourced services reside at the vendor's location. They are audited by the vendor's auditor who expresses an opinion and issue as a SAS 70 report on the control adequacy. Each of the client firms is audited by different auditor A, B, C, and D, respectively, who, as part of their respective audits, rely on the vendor's SAS 70 report and are thus not compelled to individually test the vendor's control. Given that a vendor may have hundreds or even thousands of clients, individual testing under SOX would be highly disruptive to the vendor's operations, costly to the client, and impractical. So service provider auditors issue two types of SAS 70 reports. And SAS 70 type I report in the less rigorous of the two and comments only on the suitability of the controls design. An SAS 70 Type 2 report goes further and assesses whether the controls are operating effectively based on tests conducted by the vendor's organization's auditor. And in the vast majority of SAS 70 reports issued are Type 2 because Section 404 requires the explicit testing of controls, and SAS 70 Type 1 reports are of little value in a post-SOX